And welcome to Module 3, Lesson 18, More Problems on Area and Circumference. We will be talking about a couple of new things, quarter circle and a semicircle. We will do something called decomposition, which will help you calculate the area of different types of shapes, shapes that may be combinations of shapes. So get ready for lots of fun. Let's go ahead and open up with our opening exercise. Okay, before we do, I'd like to make a note about how the area of a circle may occasionally be expressed. Okay, you may indeed have something. Hold on, that was not right. No? Okay. Well, if we open up with this opening exercise here, you're going to be asked to draw a circle with a certain diameter, and then a square as well with the same diameter or same base length or height. And then we're going to take a look at a few things. But what I noticed when they were denoting or expressing the area of a circle, sometimes an area of a circle will be, for example, if you had a circle, let's say it was 15, it ended up to be 15 square centimeters, okay? And now this 15 square centimeters, of course, was the product of, pi times r squared, okay? Now this r squared right here, what they'll do at times is they'll just take that r squared, and let's say you have a circle with a radius of 2, okay, and they will go ahead and just put 4 pi square centimeters, okay, and that's not 15 square centimeters, doesn't work with that one, but pretty darn close anyway. But every now and then you may see it expressed as this, instead of just straight square centimeters. So this one, in fact, would be like something like 12.56 centimeters, okay, or square centimeters, centimeters squared. All right, so you could express it this way: 12.56 centimeters squared is the area of that circle, the circle right here, or they might express it as 4 pi square centimeters, where they are squaring the radius, okay, and then just putting pi alongside it. So don't let that confuse you. It's not a super secret, super complex way to show the area of a circle. They've actually just leaving out a step. They're not actually doing the multiplication of pi times the radius squared. Okay, just wanted to clear that up. Okay, and here's our opening exercise. It asks you to draw a circle with a diameter of 12 centimeters and a square with a side length of 12 centimeters on grid paper. And go ahead and determine the area of the square and the circle. Okay, and really important here too, because you have quite a bit of grid paper there in your binder that I had given you at the beginning of the year. Please go ahead and do this on that grid paper, and let's start working more exclusively on the grid paper when we're creating shapes. Please use your ruler to draw the lines of the square. Use your compass as needed to draw your circle. Okay, so let's work on our attention to detail and neatness when it comes to drawing circles and squares and other shapes. Okay, so go ahead and do that, and come on back. Okay, so hopefully you drew your square and your circle nice and neatly and precisely, like I have. Again, I have some extra tools here to help me be precise, though these aren't exactly precise. And as was mentioned, this would have been 12 centimeters by 12 centimeters, as it is a square. Okay, 12 centimeters by 12 centimeters. And this would have had a diameter of 12 centimeters. Okay. Right? So that's what they wanted you to do. So now to figure out the area, and hopefully you know area of a square, 12 times 12, and this is going to equal 144 centimeters squared. Okay, and now our circle, all right, now the way they've expressed it in the book, okay, they have used, and again, remember area of a circle, our formula is pi times r squared, okay, or pi r squared. Also talk about it that way. In this case, since our diameter is 12 centimeters, our radius is going to be 6 centimeters. So we're going to have area would equal pi times 36, or they wrote it as 36 pi square centimeters, or if you went ahead and just did the multiplication all the way, you would have multiplied 36 times pi, and probably the way to know what they're asking for is if they had actually mentioned, like, use pi, use 3.14 as pi, or use 22/7 as pi. In this case, they didn't ask you to do any of that, so this would have been an acceptable answer in this case. Okay, but let me just go ahead and write the correct answer down here if you had done the multiplication. And that would have been approximately 113 square centimeters. Okay? Alrighty, so let's go ahead and move on. There's a few questions here that I'm not going to bother to have you do, but let's just go on and move on to the next set of questions. And the next part asks you to brainstorm some methods for finding half the area of the square and half the area of the circle. We could look at just going ahead and if you took these two shapes and cut them out, you could fold them and you could find the middle and of course count the number of squares. Why would anybody want to do that? Okay, I'm hoping that all of you would understand that easy enough to find half of the area of the square and the circle by just going ahead and dividing what we got. Let's see, we had 113 square centimeters for the circle. Okay, all we would need to do is divide that by 2, or multiply it by 1/2 to find out half of a circle. But again, I don't want to take too much time with that. Now let's go ahead and look here. So find the area of half the square and half the circle, and explain to a partner how you arrived at the area. Okay. Well, you can go ahead and do that if you'd like right now. Just go ahead and come on back and have a couple of answers here. For half the area of the square and then half the area of the circle. Okay, so have those ready for me and come back and check it. Okay, so here's what you would have come up with. For half the area of the circle, 56.5 square centimeters. Half the area of the square, 72 square centimeters. And now this next question, very, very important, and especially important as to how you write it down. And that question is, what is the ratio of the area, of the new area, to the original area? So that's the important part, new area to the original area. And that's how it's expressed, okay, for the square and for the circle. Now they're going to be the same, so these numbers over here are a little bit more difficult to work with. So let's work with the square. So it asks for the ratio of the new area, so 72, to the area of the original square, okay, in this case. So 72 to 144, and if you went and divided those out, you would see that this ratio is 1 to 2. 1 to 2, or a ratio could also be expressed as 1/2, because that's exactly what 1/2 says, 1 to 2. So for every 1 unit in the new area, there are 2 units in the original area. Okay? So let's go ahead and have you complete this one here too. It says find the area of 1/4 of the square and 1/4 of the circle. It says you can do it by folding, but you could use any method you want. Okay, and then go ahead and tell me what is the new ratio. The new ratio of the new area to the original area for the square and for the circle. Okay, and this is for 1/4 of the square and 1/4 of the circle. Okay, so go ahead and give me the area of these 1/4, and then go ahead and give me the ratio expressed as a fraction. Would be good. Okay. Okay, so if we find the area of 1/4 of this square, we would have gotten 36 centimeters squared. Okay, and 1/4 of the circle would have been 28.25 or 28 1/4 centimeters squared. And both of those in terms of ratio are 1/4. The new 1/4 of the square and circle to the original whole square and whole circle. Okay, we can go back and look at those original square and circle right now. Let's do that right now. Okay, so if we take a look at these original square and original circle, and I have quartered them off, divided them into quarters, we can go ahead and see here. Let's just count these. Let's count the square centimeters in the square. 1, 2, 3, 4, 5, 6, 7. This one won't go. There we go. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. And there it is. 36. Oops, I'm sorry, I have the wrong tool on here. 36 centimeters squared. Okay? And that checks out. That checks out to what we figured over there before. Now, if we look at the circle, much more difficult to work with, right? Much more difficult in that sense. But we're looking, we saw that it was about 28 1/4 centimeters squared. Let's see how close we can get. So 1, 2, 3, 4, 5, 6, 7, 9, 10, 11. This and this is probably 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. This and this is probably 25, and this is like 26. So, I mean, you can see it's more difficult to do or to come up with it perfectly with a circle. Okay, so but we came close enough, and we can see that 1/4 here. Okay, 1/4 of this square is 36 centimeters squared. Okay, so now the question is, what algebraic expression would express the area of a semicircle and a quarter circle? Okay, so we need two new algebraic expressions, one for a semicircle and one for a quarter circle. Okay, and again, just to remind you, of course, the algebraic expression for a circle is A equals, remember, pi times r squared. Okay, that's the area of a circle. Okay, now what we need to know, or what I'm asking, are what would they be for a semicircle and a quarter circle? Okay, so there we go. We have a semicircle here. Okay, fill in my semicircle. Of course, semicircle is half a circle. There's our semicircle, and here one of these is a quarter circle. Okay. So think about that for a second, and come on back when you think you have the answer. Write it, of course, in terms of, in this case, A equals, and then A equals. Okay? Okay, so in the case of the semicircle, very simply, all we need to do is add 1/2 to in the front of our formula. So we have 1/2 pi times r squared. And again, this is all a multiplication problem here, so It doesn't really matter where we have each of these expressions. We have 1/2 here, we have pi there, and we have radius squared there. Okay, so 3 different expressions that we would multiply. Okay, but just for efficiency's sake, let's go ahead and keep it in that format. So therefore, it would just make sense that the formula for a quarter circle then is 1/4 times pi times r squared. Okay, so 1/4 pi r squared. Okay, in the same situation here. All right, those are our 2 formulas, 2 new formulas. Okay, so here in example 1, let's go ahead and have you try these 2. First, find the area of the semicircle here. Okay, and they want you to use pi being equal to 22/7. Okay, and the same here. What is the area of the quarter circle here? And use pi as 22/7 again. Okay, do all your work on the space there in your binder, and come on back and let's see how you did. Okay, so let's look at these solutions here. First, let's look at our semicircle. Okay, so semicircle. First, we want to always just write our formula, just so we have it at the ready. Okay, we have area equals 1/2 pi times r squared. Okay, I'll go ahead and just rewrite the 1/2, and then 22/7 is pi. Times we have our, so here we can see, and again, this is something try not to be tricked. Be tricked here, because we're talking about radius now. Okay, and while they give you 14 centimeters is the, as you can see, that's a line of diameter. Okay, so we're just looking at radius, which is going to be half of that. So that's going to be 7 centimeters. Okay, so always stay aware of that. Okay. All right. So that's why we have 7 squared there. Okay. So now we just continue writing these out, and this 7 squared is going to be the same as 49/1. And now it's very handy. We have some numbers here we can cross cancel. Okay. And you notice how I'm cross canceling all the way across this. This is a multiplication problem. Again, I can commute. I can do things like this. So I cross-canceled here, so you can see here first between the 2 and the 22, and now I'm working with the 7 and the 49. Okay, I could also do it from the first fraction to the last fraction if there still was a reason to. Okay, and then if I go ahead and multiply all those, I multiply 1 times 11 times 7. Gives me 77, and then 1 times 1 times 1, which is 1. So my final answer, therefore, is 77 centimeters squared. Okay? All right, so let's go ahead now and look at the area of the quarter circle. Again, rewriting my area of a quarter circle formula. 1/4 pi times r squared. And rewrite everything I know down here using 22/7 as pi. And continuing that, same as above, times, there we go, 36/1. This one probably not as clean, as you'll see. I cross-canceled there. Actually, I could have had one more cross-canceling I could have done. I didn't do it. Okay, and that was same as that. And I did it both as a fraction and as written with decimals there. Okay, so these are our answers here. 198/7 centimeters squared, or 28.29 centimeters squared. Now the place where I told you I actually missed an opportunity here. I want to just show you, because I think it's very beneficial to take a look at it. But if you notice here, I had this 2, and I still had a 36 over here. So I could have actually cross-canceled there. That 2 would have become 1, and that 36 would have become 18. And what I would have gotten right to this, because the fact that I had to simplify from here to here was a good was clearly evidence that I could have cross-canceled again. But nevertheless, this is our answer, or this with a, of course, centimeters squared after it. Okay. Okay, let's take a moment to talk about something called decomposition. Okay, let's talk about decomposition. And decomposition is going to is a method that is going to help us to solve problems where we have shapes that are made up of several shapes. Okay, it could be a very anxious experience if you see shapes that look like these. Okay, and of course my question to you will be, what is the area of these shapes? Now, I've made two of them here because I want to show you just a few different ways that we can decompose them. And I think some of you have heard this term before, decomposition, talked about it in the maker space. If you've taken any maker classes, to decompose something is to take it apart, just like to compose something is to put it together. Okay? So when we're looking at shapes like this, you have to say to yourself, okay, I don't know how to find the area. There's no formula for the area of this thing in front of me, okay? But I do know the area of a rectangle. And if you look closely at this, this is made up of two rectangles. I could decompose these in two different ways. So first I can just decompose right here. I can split this into this one rectangle here, okay? So then I have this rectangle. Then I have my other rectangle as well. Okay, right there. And if I went ahead and did the area of these, how easy this could be. I have, what do I have? 1, 2, 3, 4, 5. 1, 2, 3, 4. So this one here is 4 by 5. And then this one here is 3 by 1, 2, 3, 4, 5, 6, 7. And this is 3 by 7. So now I have two separate rectangles. If I find the area of the red one here, I get 20, let's just say centimeters squared. And then if I find the white rectangle, that's going to be 21 centimeters squared. And then all I need to do is add those two together because I want the area of the total shape. And then I have 41 centimeters squared. Okay? Let's add those two areas together. This was 20 centimeters squared. This was 21 centimeters squared. Okay? And now over here, I can decompose a different way. I could decompose this way if I wanted to. Boom, boom, boom. Take it apart. Now I've actually broken this up into one square right here. And that is a 3 by 3 square. As you can see, 3 by 3. So this is actually going to have an area of 9 centimeters squared. Now I have a 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. I now have a 4 by 8 rectangle. Okay, so that's going to give me a 32 centimeter squared rectangle. And if I add those two up, you notice I have the same answer, 41 centimeters squared. Okay, so I get the, of course, because they are identical shapes, and of course they would have an identical area. Okay, but I found it two different ways, and both of those included something called decomposition. Okay, so let's keep decomposition in mind as we move on to example 2. Okay, so some of these problems are some of my my absolute favorites, which include this idea of decomposition, and this is going to allow you to use what you've learned so far. And again, if you need any assistance, just go back in the lesson and to find something that might help you out. So here we go. Marjorie is designing a new set of placemats for her dining room table. She sketched a drawing of the placemat on graph paper. Okay, which is a very good way to do it. The diagram represents the area of the placemat consisting of a rectangle and two semicircles at either end. Each square on the grid measures 4 inches in length. Find the area of the entire placemat. And then go ahead, and I'd like you to explain your thinking regarding the solution to this problem. And you know, as clearly as possible. We could talk more about this in class because not so easy for me to see what you guys are doing right now. So Anyway, as Marjorie is designing this new set of placemats, now this whole thing is a placemat. I just want to clear that up. This is not cut in pieces necessarily. She's just designing it. But in order for us to find the area, she or we have decided that it's going to be easier if we do a little decomposition. Okay, and therefore we're going to look at this as one rectangle and two semicircles. Okay, so you're going to need to do a few different calculations, okay, using the area formulas that we know. All right, and one other thing to just pay attention to in here is this: each grid measures 4 inches in length. So each one of these here is going to be 4 inches. Okay, so just keep that in mind when you're finding your measures. Okay, so go ahead and do the best you can with that, and then come on back and we'll go over it together. Okay, so let's take a look at how you solve this problem. And first, as always, I like to write my areas down, my area formulas. Area of a rectangle equals length times width, or base times height, and then area of a semicircle equals 1/2 pi times r squared. Okay, so I'm going to start with the area of a rectangle. Let's watch that happen here. Okay, what I do know is I know that each one of those segments is 4 inches, so I just add those 3 4s that you see there. Okay, and that's where I got that 12 inches as being my length or my base. Do the same thing for the height or the width, and that was 8, and then 12 times 8 equals 96 inches squared. Okay, so that means the area of this, the area of this rectangle here, inside of here, all of this in here, this area, is, we've calculated now, is 96 inches squared. Okay, so we've gotten rid of that. Now there's a couple of ways to approach it from here, but I'll show you the way I did. As you could tell how I did, I actually went for the semicircle. So 1/2 times 22/7, I use that for pi. And now, let me just stop for a second here. What I knew here now is that one of those segments right here was 4, and I know that is a line of radius. Okay, that's a line of radius, so I knew my radius was 4, so I put my 4 squared. Went ahead and brought that down, made them all into fractions. Okay, did a little cross-canceling. As you can see, the cross-canceling I could do there. Came up with my final fraction, and I went ahead and did my division to get a decimal answer. It was approximately 25 inches squared. Okay, approximately. There was some decimal value after it, but it was 0.0 some odd number. So I just rounded it to 25 inches. 25 inches squared, so that means that semicircle right there was 25 inches squared, and since the other one is identical to it, it was also 25 inches squared. If I go ahead and add all of those areas, the 25 plus the 25 plus the 96, I end up with 100, and again approximately 146 inches squared. Okay, now maybe some of you did it differently. You might have actually looked at both of those semicircles, just stuck them together in your mind, and just calculated the area of that circle. Okay, I mean, you could have done that, and that would have given you the same. Would have given you about 50 inches squared, because we know the semicircles were 25 inches squared. So there you go, using decomposition to take this shape apart in its separate pieces to come up with a total area. Okay. Okay, so next question here, after figuring out the area of the placemats, just asks us to just extend it a little bit further. And they want to know, if Marjorie wants to make 6 placemats, how many square inches of fabric will she need? How many square inches of fabric will she need? And we're going to assume there is no waste, so get as precise as possible. I came up with 146 inches squared per placemat. And all I need to do, therefore, is, of course, just multiply by 6, as I think many of you figured out already. And if I go ahead and do my multiplication here, 7 to 8, 876 square, let's see, square inches of fabric. Okay, that's what I would need. Now, if you had a different number, if you had the decimal that I ignored, actually, in fact, since I did have a little extra decimal there, I might advise Marjorie to get a little bit more fabric. In fact, you might want to always go over. Okay. All right, and now down here it asks us here. Now Marjorie decides that she wants to sew on a contrasting band of material around the edge of the placemats. Now that word, edge, should make you think of one thing and one thing only. Okay, and that is, and I'll tell you now, but hopefully you have figured out the magic word. The magic word is perimeter. Okay, so she wants to sew on a contrasting band of material around the edge of the placemats. And our question here is, how much band material will Marjorie need? Okay, and that might take a little thinking. Go back to your to the diagram of the placemat. Do some good thinking. Use what you know about our newfound knowledge about circles, and not just in this lesson, but in lessons prior, to come up with up your answer, and come on back and we'll check it together. Okay, so I hope you had some success with this shape, and here's our shape. I've drawn it, tried very carefully to draw this thing, and there we go. Redrew my my placemat here on my new page. Hopefully you did the same. Maybe you went ahead and did it on grid paper. That would be absolutely super. Okay, so here it is. I have, again, my rectangle, and I'm trying to come up with my perimeter. Okay, so I'm going from here all the way around. Again, that edge is my perimeter. Okay, so that's the measure I want, because she's going to buy some elastic material to go around, not elastic necessarily, but band material that's going to go all the way around these placemats. Okay, so she just needs to know that length, that one-dimensional length she's going to need. Okay, so yeah, let's go ahead and let's start taking a look at this. What I do know is, I do know with this rectangle that each one of those sides is 12 inches. Okay, but the question is, how am I going to figure out how long that edge is right there, that edge of the semicircle? Okay, how do I do that? Well, hopefully you remembered, all of you, or at least some of you, remembered that circumference equals diameter times pi. Okay, and that was the one, the lesson that we when we looked at my hubcap, my son's hubcap, which you never used, and we rolled it along on the piece of paper towel, and we saw, and we actually could figure out that relationship between the diameter of those hubcaps and the length of its one rotation, which would have been its circumference. Okay, and we came up with this relationship here. The circumference was diameter times pi, and that's where pi actually came from, is that that look at the relationship between diameter and circumference, which is, of course, a ratio. Okay, the most famous ratio of all, pi. All right, so if we continue that, go ahead, that would be 4. We know our diameter is 4, and then we do 4 times 3.14. How do we know a diameter is 4? Well, we have it told to us right here. Here is our diameter. Forgive me, kind of goofed up here. This is actually not 4 diameter. We're looking at it again. Didn't sound right, but actually diameter is is 8. Okay, where did I get that from? And that's just this length right here. Okay, that is 8. If we look at our original diagram, that was 8 for 2 separate strips of 4. So that was actually 8. That's a line of diameter for this circle, which would have been created using both of these semicircles. So these two semicircles together, this is a terrible semicircle here actually, but these two semicircles together would have a diameter that would be worth just one of those lines. Could have been that, or it could have been this plus this is still your diameter. Okay? Anyway, yeah, so there we go. We have our diameter, C equals, or circumference equals diameter times pi, so 8 times 3.14 equals, and here's the right answer to that, 25.12 inches. Okay? So now we have 12, 12, and then 25.12 inches, which is going to be the length of both of those. So each one of these is going to be half of this. So in fact, this length is going to be what? It's going to be 12.56 inches. And this is going to be 12.56 inches. The way we could have gotten that is by just doing half of this formula here, okay? Because it's only going to be half of that circumference, okay? But I just did the complete circumference here and got this number right there, okay? Then we have 12 plus 12 plus 25, oh, I've gotten in the way there, 25.12 gives us a complete perimeter of 49.2 inches. Very, very important that we express that in inches and not square inches or inches square, because that is a one-dimensional direction we're going in. We're going only in one direction. She needs to know how long this piece of band material needs to be, okay? And it needs to be 49.12 inches. Okay, so this example 3 is going to see if you can put together many different things that you've learned and solve this problem here. So the problem here, it tells you the circumference of a circle is 24 pi centimeters. What is the exact area of the circle? Okay, what is the exact area? And remember what I told you about expressing circumference or area in that way. Okay, that should help you out. So please do draw a diagram to assist you in solving this problem. Okay, draw a circle to begin with. So go ahead and try to solve that. Go ahead, and while you're at it, just go ahead and just fill in all this information, what information is needed to solve the problem, and then go ahead and find the area. So these are just in steps if you want to just use these steps to help you out. What is your information, first of all, and what is the area? Okay, and come on back and we'll do it together. Okay, so let's go ahead and take a look at this this solution here. So I've drawn a diagram. Drew my circle and this line of radius, and hopefully you know why I need this line of radius, because I need this radius because I need that radius to find the area of the circle. Okay, so that's because we're asked it right here. We're asked for this. Our question here is what is the exact area, exact area of the circle. Okay, so I need that radius. It is the thing that I need more than anything. Okay, that's all I need. Alrighty, so I can find that radius, okay, by using what I've been given, and that is the circumference that they've given me. Okay, and that is right there. Okay, 24 pi centimeters. Okay, now what that 24 pi centimeters means to me is that means if 24 is the diameter, the radius is 12 centimeters. Okay, so I know that because this centimeter, this circumference formula here, or number here, is actually written in with the diameter next to pi. Okay, and again, I've told you that sometimes that can be the way it's expressed. It's not actually as a complete number square, sorry, in this case centimeters, but actually just slapping pi on there next to the diameter. Okay, so therefore I know that this right here is 12 centimeters, and that is all I need to calculate my area of the circle, and the area is of course pi times r squared, and I can go ahead and solve it this way, or I can simply express it or show it the way they initially showed the circumference of the circle. And in this case, where they haven't actually asked us to express or represent pi as 3.14 or represent pi as 22 over 7, we might want to actually express it this way here, just 144 pi centimeters squared. And where does that come from? Well, that comes from the fact that we know that the radius squared, in this case 12 squared, is 144, and we're going to multiply that by pi, which is 3.14, or just the symbol itself. Okay, so we could, either one of these would be correct. Probably more correct in this case would have been the second one here. Okay, but I mean, I don't know more correct. They're both correct. So if you did one or the other, you did very well. Okay, so now we're going to finish up with some exercises. We have, let's see, 4 exercises here. Let's go ahead and do these one at a time. And number 1 here says, find the area of a circle with a diameter of 42 centimeters. Okay, and now it says use pi equals 22 over 7, so we're going to need a full, complete answer at the end. Okay, so go ahead and give that a whirl and come on back. Okay, so here let's go ahead and solve this exercise 1. Again, firstly, just write down my formula, fill in with what I know. Okay, and as you can see, I figured out that 21 squared is 441, and then I very cleverly went ahead and divided 441 by 7, just in case I did get a whole number, a number without a decimal value, and I did, very lucky. And there we go. 22 times 63 is 1,386, and that's over 1, so 1,386 centimeters squared would be the area of this circle with a diameter of 42 centimeters. Okay, so let's go ahead and do number 2. And number 2 here is asking us the circumference, whoopsie, wrong, boop. The circumference of a circle is 9 pi centimeters. Okay, 9 pi centimeters. Let's go ahead and pay attention to the way they've expressed that, all right? So you go ahead and tell me what its diameter is, its radius, and its area. It's amazing you're going to be able to come up with all of those just with this one little piece of information. Okay, so go ahead and give that a whirl. Okay, so let's go ahead. The circumference of a circle, well, we just did this already, right, is 9 pi centimeters, okay? Oh, didn't I go through all this already? I'm sorry. But here, we're going to start from here. So, circumference we know is diameter times pi, right? Well, the way it's expressed here is 9 pi centimeters. Well, therefore, that 9, we know, is going to, of course, stand for diameter. So the diameter, and I am talking faster than this is writing, diameter is 9 centimeters. Okay? Pretty simple to look at that one. Alrighty? So, okay, now we're going to go ahead and say, what is a radius? So if the diameter, let me get this thing going a little bit faster, if the diameter equals 9, then the radius, of course, is half of that, which is 9 over 2 centimeters, or 4.5 centimeters, okay? So the initial one could be preferred as 9 over 2 centimeters, okay? And lastly, what is the area? Well, we know area equals pi times r squared. Let's talk about that r squared. We have the r, which is 9 over 2. Now, let me be very careful in this. So now, when I square a fraction, very, very important, and it's something maybe some of you have just done. This will be your first time ever doing it, okay? Very important, and we'll probably have to talk about this much more later on. We are going to square both the numerator and the denominator. Okay, therefore I put it in the parentheses. So I am going to square 9 and use that as my numerator, and then I'm going to square 2 and use that as my denominator, and that's going to come out as 81 over 4. Okay, 81 over 4, and that is 9 over 2 squared. And then here comes my pi centimeters squared. So now that they initially set this up with, well, I don't know. Oh yes, they initially set this up this way with showing the circumference as 9 pi centimeters. So we just went ahead and just used this notation instead of going ahead and calculating with pi. Okay, so this is a good answer right here. Okay, so here we go. Number 3. If students only know the radius of a circle, what other measures could they determine? So explain how students would use the radius to find the other parts. Okay, so let's just talk about that. Okay, we don't need to go away and do this. Let's just talk about this. Yeah, so what can you do with radius? Okay, so if you know the radius, you can find the diameter, right? Because the diameter is going to be 2 times the radius, 2 times the r, so we can get the diameter, right? And the circumference can be found by doubling the radius, okay, to get diameter, okay, because we need circumference. We got circumference from the remember circumference formula is circumference equals diameter times pi. So if we have the radius, we can just double that to get the diameter, and then we can multiply that times pi to get the circumference. Okay? All right, and let's see what else. And the area, then, therefore, can be found by multiplying the radius, if we had the radius, by itself, which is squaring it, okay? And then multiplying that by pi, okay? So area equals that. Therefore, if we have the radius, we pretty much have the ability to solve for diameter, circumference, area. Pretty much that is everything we need. Alrighty, so here we go. Fourth and final exercise to end this lesson, and then we'll close, and you can get on your way doing the rest of your work. Find the area of a rectangle between the 2 quarter circles if AF equals 7 feet. And that's right here. FB equals 9 feet. HD equals 7 feet. Okay? So let me just go ahead and write those down for you. You can. I'd like it if you did as well. These are all in feet. AF here is 7 feet. FB is 9 feet. HD is 7 feet. Okay? Now we want to know the area in the rectangle between the 2 quarter circles. So what we are looking to find the area of is trying to get a new color here. New color on my, okay, I'm not going to new color, I'm trying to get a new color. Doesn't that work? Here we go. There we go. I'm sorry, I'm just getting a new color for my pen. We're going to go ahead and find the area of all of this. Okay, I'm helping you out a little bit here, but that's okay, because hopefully this will help you solve your problem sets. Alright, so this is what we're looking for. Okay, we are looking for that, the area of that space, really weird looking space. So we're kind of decomposing this thing, okay, using what the measurements that you've been given, okay, in the problem. So go ahead and do your best, and come on back and we'll look at it together. Okay, so here we go. Let's solve this problem. We're trying to find out the mystery area, the question area, what the area is of that space right there. Okay, so here we go. Let's go ahead and start with these quarter circles here, and our our formula of a quarter circle, area of a quarter circle is quarter fourth times pi times r squared. Okay, go ahead and fill in all these numbers. And we get to that point right there. Okay, so we have 1/4 times 22 over 7, because we were told to use 22 over 7 for pi, times 49 over 1, because that is our radius squared. We can see our radius, of course, right over here. Okay, the radius of that quarter circle. Okay, so go ahead and let's just do a little cross cancellation. Lots of cross cancellation here. Beautiful. And that's going to equal then 77 over 2, which is about 38.5 feet squared. Now there's another way to do this, and we'll talk about that in a second, but both of those quarter circles therefore are going to be 38.5 feet squared. Add those two together and we get 77 feet squared is how much area those two take up. Therefore we need to get rid of those. We need to take those away. Again, we can't do anything with that silly looking shape in the middle, a kind of a kite looking shape, but we can figure out the area of the entire rectangle, okay, using some key bits of information, the length and the width, or the base and the height. We had 7 and 9, and that was 16 for our base or our length. 4 plus 4 was 7 plus 7 is 14. And if we go ahead and multiply those, we end up with 224 square feet is the area of the entire rectangle. Take all of that, then go ahead and subtract away those quarter circles, and you come up with 147 square feet. And that would be the area of that kite-shaped space there between the quarter circles. Okay? That's a lot of fun. I think that's a lot of fun. Take some time. Got to use multiple formulas, multiple information, pieces of information. The perfect type of problem for me. And I hope you guys and girls are feeling more confident with problems such as these. Okay, so in closing, a few points here. Firstly, the area of a semicircle, okay, is actually a semicircular region is half of the area of the circle from which it was derived. Okay, and that word derived means from where it came from. The circle it came from has to be. Okay, it can't be any semicircle. Okay, because if I had a circle, all right, the only semicircle that's going to be half the area of that circle is one that came from that circle. Okay, so just very important. You can't say like this semicircle is half the area of that circle because it didn't come from it. Okay, so that doesn't work. All right. Okay, so yeah, next point we have is problems that involve the composition of multiple shapes. Okay, may be decomposed. Important word there, decomposed, to assist in our solutions. Okay, and that decomposition can take several forms. As long as we are decomposing the shape into shapes with which we know how to work. We know how to work with rectangles. We know how to work with squares, semicircles, quarter circles. Those, if we decompose them in that way, we can find the area of the various parts, add those together, or in some cases subtract them away like we did in the last exercise to come up with our final solution. Okay? Well, I hope you enjoyed this lesson. I did, and look forward to seeing you, or whatever, lesson 19.